Algebra 2, very first video of the semester. And welcome. Here is Unit 1, Day 1 video. Here are your notes. Unit 1 has a lot of review from Algebra 1, so hopefully this looks familiar to you and you will be able to get these concepts down comfortably if you don't already have them. So let's get right into it. Graphing vertical and horizontal lines. We are going to first graph this line. It's listed here with a set of ordered pairs on the left. They gave you some XY coordinate pairs, and we'll take the first point, which is -2, -3. So if we go left 2 units and down 3 units, should be right about at that point right there, right? The next point that we have, -2, -1. Your second point coming in at that spot, -2, 2. So left 2 and up 2. And then finally, they give us -2, 5. So we want to go all the way up to 5. There we go. So since this is a line, we are going to connect our dots. Lines extend forever in 2 directions. So what did you notice about this line? Well, it is vertical. And if you look at the ordered pairs, you should notice that every single x coordinate is -2. So the equation of this vertical line is x equals -2. And if you go back to your Algebra 1 days when you were probably taught Hoy-Vux, this part right here, the VUX, vertical lines, that's the V, have undefined slopes, that's the U, and their equations always look like x equals a constant, like this. That's the x. So in Hoy-Vux, that's what VUX stands for. Vertical lines have undefined slopes with x equals a constant. So let's change our color up here, and let's take a look at the second line. Okay? The second line has the point -2, 3. So left 2 and up 3. Has the point 0, 3. Has the point 2, 3. And it has the point 4, 3. Okay, we connect the dots. Okay, and now as far as the line, the equation here, hopefully some of you, if not all of you, have kind of figured out, oh wait, this was a horizontal line. Horizontal lines have a 0 slope, and they have an equation of y equals a constant. Well, if you look at this table, you notice that the y coordinate is always 3. So your equation here is going to be y equals 3. Okay? So that's the Hoy part in Hoy-Vux. Horizontal lines have 0 slope. Y equals a constant is going to be your equation of the line. Okay, let's move down the page just a bit. So now this section of your page talks about the definition of a function. So a function is a relation, okay, so it's a group of ordered pairs, in where every value in the domain, which is x, has only one value in the range paired with it. So that means that if I have 1x, it is paired with 1y, and only one y. Okay? So if I say x is 3, what is y? If you give me one answer, well, that's a function so far. If I say what is 3, if I say what is y when x is 3, and you give me, 1 and -2, so 3, 1, and 3, -2 are both answers, that tells you it's not a function. A function, by definition, has for each input, for each x, you only have one y coordinate that it corresponds to. So when you graph such a thing, it talks here about the vertical line test. Vertical line test basically tells you that if you have a graph, so let's say we got this red graph, right? And I draw a vertical line. So we draw a vertical line here. This vertical line only touches the graph once, because at this x coordinate, there are no other y coordinates than this one, all right? So no matter where I draw vertical lines, the red graph only intercepts a vertical line once. Okay? That tells me that that red graph is a function. Now, if you look at the blue graph, if I draw a vertical line and I see that it intersects twice or more than once, if it intersected more than twice, that would also be an indicator that this is not a function. Okay? So this one up here, function. This one right here, not a function. Okay, so if we look back here now, graph passes vertical line tests. You're not able to draw a vertical line, so it touches the graph more than once. Okay, we just looked at that. Okay. Now, function notation. When you were in Algebra 1, it was always y equals mx plus b. Okay. As you get older and more sophisticated, we don't just say y, we say the function of x, in this case, f of x. This is just another way to name a function. You say the name of my function is y, so y equals this. Now it's f of x equals this. Now, does it have to be f? No, it could be g of x or h of x or L of x. But we start with f of x just because function begins with f. So f is the name of this function. X is what we substitute in to the equation. Okay? This is your input. And then your function here is 2x. Okay? It says that I'm going to take 2 times whatever the x input is. Okay? So as I said, it's just a little more sophisticated way of saying y equals. We're going to go f of x equals. Here's a visual. So this is one to remember. And y equals was a basic, everyday normal way to talk about a function. F of x, classy, just classy. Okay, so with that in mind, let's continue on to the next page. All right, so now what we're going to do is we're going to take 2 different methods of graphing a line. Right? First method that you're very familiar with, I'm sure, is a table. And take a table of values. We used to just call it x and y, but now we're looking at it with a little more sophistication, a little more class. So it's x and f of x. Okay. Now x is your independent variable, which we're just going to choose x's. Now choose wisely. Choose easy x's. If you have a fraction in your slope, in your m, that you're going to multiply x by, make sure that you multiply by factors of the denominator. So like, I don't want to multiply this by 5 because 5 times a half is a decimal. And I don't have any decimals on my units. Okay, I don't have it on my grid. So what I want to do is I want to use multiples of 2. So let's go with 0. Let's go with 2. Let's go with 4. Let's do a negative one also. Let's go negative 2. Okay, so let's graph this. First, we have to find the y-coordinate, or f of x coordinate. So how do we do that? Let's take the 0. So we substitute 0 in for the x. You get negative 1/2 times 0, which is 0, plus 3, which gives you 3. Okay, that's not bad at all. Now let's take 2 and substitute it in for x. So negative 1/2 times 2, which is negative 1, plus 3 gives you 2. Let's take 4, substitute it for x. Negative 1/2 times 4 is negative 2. Plus 3 gives me 1. Let's substitute the negative 2 for x. Negative 1/2 times negative 2 is positive 1. Plus 3 gives me 4. Now my table is filled out. If you remember in geometry, 2 points will constitute a line, but we'd like to get 3 or 4 just so that, if you made a mistake on one point and you only use 2, you're just going to connect the dots and you're going to go in the wrong direction. If you connect these points and it's not linear, and you use 3 or 4, and you see like one point is off, then it's a good way to check that maybe one of those points is wrong. So let's plot these points. Okay, 0, 3, going to be right there. 2, 2, the ballerina is going to be right there. 4, 1, right there. Okay, and negative 2, 4 is right there. Okay. And if I connect these with a straight line, it can go through all of those points. Looks like we did a pretty good job on that one. Let's change it over to green, and let's look at another method of graphing a line. This one is the Slope-Intercept Method. Whenever you have y equals or f of x equals, or in this case g of x, same thing, equals. Okay, remember, this is a y. But if you remember mx plus b, then remember that positive 2 is the mx plus b. So that means your b is negative 1. All right, so what we're going to do is we're going to first plot the y-intercept, plot the b. Okay? So b is negative 1. We're going to go right to negative 1 on the y-axis, and we're going to plot that point. Okay? There's your first step. Your next step is to figure out what your m is. Your m was a positive 2. The x is not part of the m, okay? If I say what is m, it's always going to be a number. Okay? Rise over run. So m is going to be 2. And invisible math says I can put it over 1, and I'm not going to change the value of my number. Okay? So we've already got b is at negative 1. Now let's find a second point by rising 2 and running 1. Now these are both positive numbers the way I've written it, positive 2 over positive 1. So if I rise 2, 1, 2, and I run 1, then that's a point. You can do it again. Rise 2, run 1. There's a point. Rise 2, run 1. Okay. Go as far as we want. Just remember, if we needed to go in the other direction, then let's say that that was the top of my grid paper, right? And I needed to go one more point. Maybe your teacher said, I want 6 points. You go, I've only got 5. Well, there's no more grid up here in this area. What can I do? Well, just remember, if you want 2 over 1, a line goes in 2 directions. It also goes, in this case, left, not just right, infinitely. So if you start back here at the y-intercept, we can go down 2 and left 1. So negative over negative is also a positive slope. So down 2, left 1. Down 2, left 1. Okay? So, let's try that again. Almost. There we go. Teamwork makes the dream work. All right, so we just used the slope and intercept method of graphing, okay, which that's my favorite. I like just plotting the y-intercept and then doing rise and run, and then I've got my second point. You can do as many points as you want. It's pretty cool. Yeah, so let's proceed on to the next page. I'm sure that you heard y equals mx plus b at least 100 times when you were in Algebra 1, maybe even a little bit in geometry. So y equals mx plus b is called the slope-intercept form of a line because the m represents the slope of your line, the rise over the run, the steepness, the incline, the slant. The b represents the y-intercept, which is the point where your line intercepts the y-axis. Positive slope rises to the right. Okay? Remember, we always go left to right, just like when you read. We read left to right. So it's like you're going uphill. Negative slope goes down or falls left to right, going downhill. Horizontal line has 0 slope. Vertical line, slope is undefined. And okay, so maybe you like to utilize the slope dude. Slope dude is skiing up and down slopes. So he's working hard to get up the slope, because remember, we always go left to right. So he's going up the slope, that's why it's puff, puff, positive. And he's going downhill and it's easy and it's nice, negative. And then he has to work cross-country skiing. And he said, this is 0 fun. It's like 0 slope. And then he gets the vertical part and he's toast. And that's undefined. Okay, so if you needed a little extra help to memorize those, feel free to use the slope dude. Okay, now to the last page. Okay, I know this is a little bit, at least it looks a little bit fuzzy on the left side, so I'll read what it says here. The first equation says y equals x plus 9. Okay, so y equals x plus 9, and it's asking us to identify whether this is linear or not. Okay, is this a linear equation? Okay. So linear equation, yes, this is. This is actually in y equals mx plus b form. Okay, don't forget y equals mx plus b from the previous page. The second one, y equals negative 3x cubed, or x to the 3rd power. Is that linear? So there's an x cubed, x to the 3rd. Right? Because mx plus b has an x that doesn't have an exponent written, it's like invisible math. The exponent is 1. Okay? You don't have to write it. It's like saying 1x and x is the same thing. X to the 1st and x are equivalent. Okay? They're the same thing. They mean the same thing. So if you have x in your equation, it must be to the 1st power for you to have a linear equation. Okay, so let's finish these last two. This is y equals x squared plus 7. Because it's x squared, we have a great big no. As a matter of fact, if you graph this, it's a parabola, as many of you know, I'm sure. And then this last one is y equals 4 to the x. Now, anytime you have x in the exponent, it's not a line, okay? You graph this if you want on a graphing calculator, and you'll see it's definitely not linear. It's not a straight graph, okay? So, conclusions. Well, what can we say about our conclusions from these examples? Well, first you can say that x must have an exponent of 1. Okay? In your equation, if there's an x, 1 is the exponent. Second thing that we just looked at is that if there is an x or any variable in the exponent itself, it's not linear. Okay? So those are examples that go with your conclusions. Okay? Now, linear as far as your ordered pairs. If I just give you, instead of the equation, if I just give you an XY chart. Okay, so let's look at this one on the left first. Okay, notice that we increase the X coordinate or the X value every time by 1. Okay, so the X value is going up constantly by 1. So we'll say +1, +1, and +1. Okay, so you're adding 1 to each x. So let's see what you're doing to the y coordinate. From -4 to -5, you're subtracting 1, or you're adding -1. From -5 to -6, you're also subtracting 1. From -6 to -4, you're adding 2. Okay, so because we had consistent adding 1 for the x's, and you had almost consistent but not quite, we had an inconsistent pattern with the y's. This one is not linear. Okay, so we would say this is not a linear graph. And if you plotted those points, you'd see that you got 1, 2, 3 of them that are on the same line, and then you'd have one of them that would be off a little bit. Okay, so let's look at the second one, the one on the right here. So we're going +3, we're going +5. Okay? Let's see what happens here. +3, +5, +3. Oh, look at that, +5. So this one is linear. If you remember in Algebra 1, we looked at the change in y, y2 minus y1, over the change in x, x2 minus x1. That was slope, okay? So if the slope is consistent, in this case, it would be a 5/3 slope. Then consistent slope means you're gonna have a linear graph. Okay? So this is linear. So change in y over change in x, or slope, is consistent for every pair of points, okay? From the first two to the last two and all in between, it's always going to reduce to the same rise over run, okay? And then obviously if you plot them on graph paper and connect them with a straight edge, you will also see that they are linear. Okay, so that's day 1 notes. Hopefully you are going to be able to confidently go after your day 1 practice. If you have any questions, feel free to either message me in Google Classroom, send a question to my school email. You can ask me to add you to a flex period coming right up. If you want to Zoom during that time, or if you are in person and you want to come in during flex period, you just have to touch base with me there and we can take care of that. So anyway, that's it for the first video. Okay, here's to a bunch more.